Hi guys. Okay, so my name's Zara. We're going to be talking about the GCSE Foundation, and we're going to be running some sessions which will start at 4, depending on the subject, will end at various different times through the course, through this course, if you like. So what we plan on doing is going through session by session all the topics, a quick overview, but the main bit and the best way to do maths is obviously just by doing questions. So we're going to work through some questions. They'll be linked below. I'm a bit rubbish at a lot of the technical stuff, so I have somebody who's helping me with that. So bear that in mind if you're waiting for the links. I'll try to put them up as soon as the session is live on YouTube. Okay, so let's start just generally talking about resits though. So this is for information for anyone considering resits in any subject. You can resit. I know you didn't take an exam necessarily in the first place because you had all these assessments and lots of exams, but you can officially resit the exams in either autumn, which is the October-November timing, which is what we're aiming to right now, or next summer. So that would be in May time, okay? All GCSEs and all A levels are being offered. Some of the AS are not, but we don't need to worry about that too much. Art and design, as opposed to being a portfolio that you put together, will be assessed by the exam board, but will be one set task. There'll be written exams for some subjects, where maybe there was some coursework before, but they'll only be written exams. You can carry forward any practical endorsement, meaning your teachers have to sort of tick a box for science to say they looked at all the experiments, so that will be the case. And then once you get your grade, if your final grade will be the one that's highest. So if your assessment grade that your teachers gave you ends up being higher and you end up doing worse on your resits for whatever reason, then you stick with your original results. Now, in order to enter, speak to your college, your old school, your current college, but the deadline, particularly for A-levels, is coming up. So make sure you get that entry in. And if you're having any problems, we can help you maybe draft an email, but get on the phone and just annoy your school, your old school in particular, if your current school or college won't let you do it. And yeah, so we've got timetables. Today we're going to be looking at like number and structure. So this is back to the course, which is hopefully nice and straightforward. Now you'll have to bear with me today. We'll figure out technologically the best way to do this. So we'll figure that out today, because this is the first time we're doing it. So hopefully this works. I'm going to use my iPad, and you should be able to see me write on it while looking on the screen at other bits and pieces. So let's see if this works. Give me 2 seconds. Right, so while we're also talking about this, anyone doing this research, you're going to be absolutely fine. I hope you do know that, and that this is literally not going to, and it doesn't matter if you're finding maths difficult, if you've taken it 2, 3, 4 times, I can probably find you somebody who's taken it more times and they've been absolutely fine. So you guys have got this and it's going to be fine. All right, let's see if this works. So, yes. All right. So you should now be able to see the first session. You will have access to this. There'll be a link for this sheet. There'll be a link underneath the this course, and we'll put links up in the Google Classroom and wherever else we can. So in order to be able to start thinking about it, we've got to think about all our different types. Now, I don't want you to worry too much about this. So words, like this is maths, it's not about words. But sometimes a question will say, show your integer answers. And you're like, what's an integer? An integer is essentially a whole number. So the really important thing is to know is that we know what an integer is, which is a whole number, and something that's not an integer could be a fraction, yeah, like a half and a quarter. Now, if something can't even be written as a fraction, so all fractions can be written as a over b, as some sort of, all rational numbers can be written as a over b, so even as a fraction. And if it's irrational, it can't even be written as a fraction. Right, I will edit this first slide to show you it, to explain this a little bit better as well, and put some examples in there. Now, obviously, a negative number is less than 0. A multiple is in your times tables. Hopefully, you're happy with that. So multiple and factor. Make sure you've got those in your head. So a multiple is in that numbers times table. So a multiple of 3 would be 12, because in your 3 times table, 3 times 4 is 12. So your multiple is always bigger, if you like. So the multiple of 3 is going to be bigger than 3, whereas a factor is something smaller that a number divides into. So remember, some questions will ask you for a factor, will ask you to identify a prime number. Now just learn the first few, 2, 3, 5, 7. If you're not sure, use your calculator, and I'm going to show you how to do that. And your calculator can tell you, as long as you know what number you're testing, what prime number you're looking at. Okay. So we then have BODMAS. Now, some of you, if your teachers were a bit old-fashioned, or might have used BIDMAS, but BODMAS, it tells you the order in which you do things. Now, if you do enough questions, this becomes a little bit intuitive, but generally B stands for brackets. Do your brackets first and do the adding and subtracting at the end. So your brackets go first, weird stuff second. So any squaring, any indices, and so on. And then division, multiplication, and addition, subtraction. But hopefully that in your head will make sense. And if you look at indices, so if something is squared or cubed, we're not going to worry about them too much. If you're aiming for the higher end, you're going to have to worry about them more. But the ones that you need to know are generally when you multiply indices, you're adding them. But honestly, we're not going to worry about it too much. So what I mean by that is that we're going to have, for example, if we had x squared. Now, why they use x's everywhere, I have no idea. Times x to the 4. It'd be so much easier if they gave us numbers. But x squared, so anything squared means the number multiplied. And can you see, I've tried to make a difference between the x and the multiplication sign. So I make mine curly just to make it look different, so it's easy to see. So x squared, or anything squared, means something times something. Then I've got x to the 4, which is essentially 4 of these. So now if we add them up, we can see you've got 1, 2, 3, 4, 5, 6. So that's x to the 6. That's what that means. So let's do it with a number so it might seem easier. 3 squared times 3 cubed. 3 squared is 3 lots of 3. I mean, 2 lots of 3. It's 3 cubed, I was a step ahead of myself, is 3 lots of 3. So times 3 times 3 times 3. So essentially it's 3 times 3 times 3 times 3 times 3. So you've got 5 of them, so that's 3 to the power of 5. It's not the same as 5 times 3, right? Because we know 5 times 3 is bigger, so if you take 3 squared, 3 times 3 is 9. That's 9. 3 times 3 times 3, that's definitely going to be bigger than 15 before we even start. So that's what you've got to make sure. That's the biggest mistake students make with this, which we're not going to confuse it. Okay. But I'm just zooming through these. Essentially, what's going to take the time is going to go through the questions really slowly and at the same time, think about the topics. Mainly for this one, the other topics are a little bit more structured where we can go through and it require a bit more of note taking. But essentially for anything within this topic, it's just doing lots of questions. And if you need extra practice questions, literally if you Google number foundation, loads and loads will come up. Okay, so just quickly, prime factors, we're going to go through highest common factor and lowest common factor. I'm going to show you how to do it with your calculator and also if it comes up in a non-calculator paper. Okay, so with your calculator, it's super easy, right? Okay, standard form, again, generally you'll get used to use your calculator with it and it becomes super easy. And if not, it doesn't matter. We'll show you how to do it when we come across some of the questions. Okay, so let's have a look at the non-calculator questions first. Now, this is a question 9. This is towards the end. I'm not quite sure why I've put it first, so, but it's towards the end of the exam paper. So you're not going to worry about this question too much. This was the one of the questions that will be on the higher paper as well as the foundation paper. So you've got 36 to the power of a half. Now what you're going to do is from those indices rules up here, you're going to learn a few things. Okay, so we just need to adjust some of these notes. Okay, so you're going to learn a few bits and pieces. So what you're going to learn is that on that crib sheet up above, we've got anything to the power of a half is always square root the number. So you're going to have a look at that and you're going to make sure that if you square root 36, you're going to get 6. Okay. One of your other rules, again, we'll highlight it. We'll adjust the sheet so those rules are really easy for you to see. If you've got anything, so here we've got to the power of 0, is going to always be 1. So me to the power of 0 is 1. We could have 1,000, 2, 3, 6, 7. Doesn't matter what it is. Anything to the power of 0 is always 1. And remember, a square root means what times what gives you that number, right? This would be on a higher paper, so we're not going to worry about that question unless we want to try going for full marks. Okay, so now we're going to think about factors. Okay, factors. So remember, which one was factors? Was it the smaller one or the bigger one? So you're going to say, okay, the smaller one is what factors is. So factors is everything in which 18 is inside its times tables, right? So you just have to think about it. You're going to go, okay, is it in the 1 times table? Yes. 1 times what gives me 18? So 1 and 18. Is it in the 2 times table? Well, it has to be because it's an even number. Remember, even number ends in 2, 4, 6, 8. So because it ends in one of those numbers, we know it's 2 times something. So what is it? Hopefully we got that 2 times 9. So every time you know one of them, you also know your other value. Right, now let's go up 3. Is it in my 3 times table? Now a trick, if you have a longer number and you want to know if it's in the 3 times table, you can add up the digits. So if I do 1 plus 8, I get 9. Now 9 is really high up in the 3 times table. So I know that 9 is in the 3 times table, 18 is in the 3 times table. So 3. And I don't know whether anyone's ever taught you to put your fingers down. You can figure out where, how many, but hopefully we know that, you know, how to get 18 from 3. That's for your 9 times table. Sorry, ignore me, not 3 times table. But that would have given you your 9 times 2. So 3 and 3 times what gives you 18? 3 times 6. Okay, so that's literally just looking at your times tables, which I know you maybe sang when you were little, but they're one of those things that you just need to know. And if not, just scribble them down on the side. If you're like, you know, if you learnt them as 2, 4, 6, 8, 10, and you have to think about to get to it, just scribble some numbers down. You can write as much as you like, scribble all over the paper if you have to. Right, we're now going to look at the lowest common multiple of 12 and 15, right? And there's 2 ways to do this, and it depends which way you were taught it. I'm going to show you what I think is the easiest way to do it, but then I'll also show it to you using prime factorization in case that's what you're asked for. So the easiest way, I think, to do it is to write 12 on the top. It doesn't matter which one you're on the top, it's just easier to write it. So 12 over 15, okay? And then what you're going to do is you're going to cancel that down. You're going to say what goes into 12 and into 15. So hopefully you can realize 3 does. And so that as its simplest form becomes 4 over 5 because I've divided the top by 3 and I've divided the bottom by 3. So once I have the fraction in the simplest form, in order to find the lowest common multiple, all I have to do is I have to multiply a diagonal. So I'm going to do 12 times 5, which gives me 60. Now, if you had to on the side do a little sum, so 12 5s, because you'd forgotten what it was, it doesn't matter. 5 2s are 10, 1 times 5 is 5, plus 1 gives you 60. That's also okay. So 60 would be your lowest common multiple. Right, so I'm going to show you how to do it using prime factorization just in case you don't have to do it like this. It's number one, the way you were taught, but might have been taught, but also sometimes the question might say, using prime factorization, show that. Okay, so let's take 12. And we say to ourselves, can we divide it by 2? Yes. How many times does that go? 6. Now 2 is a prime factor, so we're done. Then we're going to take 6 and say, can that divide by 2? Yes. And we get 2 and 3. Now remember, those are all our prime factors. Now we're going to do the same for 15. Does 15 go into 2? No, it's not even. Does it go into 3? Yes, it's 3 times 5. Okay. So then what we end up doing is we can do, we say to ourselves, what is the most amount of 2s? Well, that's 2, isn't it? So we've got 1, 2, lots of 2s. So 2 times 2. We've got 3. 1 3 is the most amount of 3s, and 5. And if you do 2 times 2, you get 4. 4 times 3 is 12. 12 times 5 is 60. So that's using prime factorization. So like I said, you use whatever is easiest for you. However, this is what I think might be easier, or I think using a fraction is much easier. Although some people get scared by fractions, I understand. They're a bit annoying sometimes. Okay, so now we've got a standard form question. Okay, important rule. You need to find the number between 1 and 9. In 1 and, 10, if you like, but not including 10 in this. So we're like, okay, where is the number? The number is here. You got 97. Now that's too big. How do I get it between 9 and 10? I'd stick a decimal place there. So that's your first step. So the only way to do that is to put a decimal place there. So we put that in 9.7. And then we count. And we're going to do 1 jump, 2 jumps, 3 jumps, 4 jumps. So I've done 4 jumps backwards, right? So 4 jumps to the left. So I'm going to do times by 10. And because it was backwards, it's a small number, minus and how many jumps I did. Okay. Again, these are like, as you can see, questions that are towards the end of the paper. Because to be honest, a lot of the number stuff is multiplying and dividing, which we will look at when we do a full foundation paper, if it's at the start of it, but they're only worth a few marks. So this is the bit which gets you from that level 3 to getting your pass, to getting you through to the level 4, 5. So some of these might be tricky and also in the higher paper, but if you know the rules and you can do them, you should be okay. And if some of the basic functions still you find difficult, what you need to do is go look at videos very particular to them. So if you're still confused about, or you struggle to multiply, doing long multiplication, just have a look at a quick long multiplication video. You'll never have to do probably something so big. It'll be no more than what we've done in some of these questions, but it's okay. Have a look up a long multiplication video, put something in the comments going, I can't do long multiplication, and maybe we can make a really short video for you. But generally, this first topic, I'm hoping should feel relatively easy to just read through the notes, but then some of the questions we're doing are on the trickier side because that's how they test it. Yeah, they're very mean when they come to these. Right, so now they're saying, work out these. Now there's 2 ways to do them. If you are comfortable with the indices, we could do them using indices, or you can just work them out in full. 3 times 10 to the 5. So whatever number, right, if that's a positive number is after that, it just means that you either move the decimal place, there's none of them, or you add that many zeros. So we're adding 1, 2, 3, 4, 5 zeros. And on the bottom here, we're taking the 4 and we're adding 3 zeros, okay? Because you're timesing it by 10, then timesing it by 10, then timesing it by 10. Now we can cancel out the zeros. So there's a 0 on the top, we can get rid of 1 there. There's 1 there, we can get rid of that. That one, we could get rid of that. And then we've got 300 divided by 4 left. Okay, it's always easy to half. So let's half it first, okay? So 300 halved is going to give us 150. And then we've got it over 2 because 4 halved is 2. And then dividing by 2 is the same as halving. And we're going to half again. Now, halving is a trick that you should be quite good at or should get quite good at. So if you think about it, 150 is made up of 100 and of 50. Yeah? Half of 100 is 50. And half of 50 is 25. I add those up and I get 75. So as an ordinary number, my answer is 75. Yeah, okay. Right, let's think about this one. We've got 4 positive whole numbers. Okay, we can do that. 3 marks, so I'll show you how the marks come up as well. So first of all, we know we can't have any negative numbers. We know that they add up to 84, okay? One of the numbers is a multiple of 17, all right? So let's think, what does multiple of 17 mean? It means something in the 17 times table. So 17 times 1 is 17. 17 times 2 would be, 17 plus 17. Yeah, or we could do the doubling trick. So we get 34. And then times 3, we'd have to add another 17. So you do 7 plus 4 to give you 11. And then 3, 4, 5, 51. And I could have another 17, 8, 68. But we're probably going to see that at some point we'll leave those there for the moment. And we'll say, okay, and the other 3 numbers are equal, right? So when we then take away whichever value we use, we're going to have 3 numbers left, which are going to give us something that's equal, right? So what we're going to think about first, well, if we're taking away 17 or 34 or 51 or 68, we want to be left with a number that divides by 3, because there's only going to be 3 numbers left that we have. Now, this is a positive number. Oh, so here, 84 is a positive number, right? Okay, well, we can just try a few. That might be the easiest thing because there's only a few here. You can do 84 minus 17 minus 17. So you're going to do, that's going to give you 67. That doesn't go in to 3. Remember our trick? We can do 6 plus 7. Definitely doesn't go into 3. Right. 84 minus 34. 0. 50 doesn't go into 3. 84 minus 51. And now equals 3 and 3, 33. Yes, that's one of the easiest times table. That's our 11 times table. So 33 divided by 3 we know is 11. So therefore we know our 4 numbers must be 51, 11, 11, and 11. So what you might find is if you've seen this question before, then maybe somebody's done some algebra, 17x plus 3 something equals this. It doesn't matter. Just think about it logically. No one's telling you need to know your 17 times table. You just need to be able to work it out. So you need to add quickly and subtract. And even not even that quickly. It's 3 marks, which means you've got 3 and a bit minutes. So you've got kind of double, or 4 and a bit minutes. You've got double the time that it's taken me to do it. So you've got enough time. Just go slow, think it through, and think logically. Right, next question. Margaret is thinking of a number. She says, my number is odd. It is a factor of 36 and a multiple of 3. There are 2 possible numbers she can be thinking about. Write down these 2 numbers. So it's in the 3 times table, but we can divide it by 36. So what will be easier? Obviously, the 3 times table goes on forever. So what will be easier will be to write out the factors of 36. So we're thinking, what numbers give you 36? So we're going to say there's 1 and 36. There's 2 and 18. There's 3 and 9. There's 4 and 12. And then there's, so let's see what else. Have we come across things actually? Wait, before I stop, I should probably, as I go, write them down. So 1 and 36. There are 2. And this is even, so we don't want this, we don't want this, it's even. We've come across odd number, these are even. Okay, so we've got our 2 numbers, 3 and 9. Sorry, I could have kept going, but there was no need. So we can check it as we go along. Okay. Right, write down all the prime numbers between 20 and 30. Right, now either you learn these, now you might know them. Now if you don't know them, what you can do as well is write the numbers between 20 and 30. Okay, so we're going to write the numbers between 20 and 30. So we've got 21, 22, 23, 24, 25, 26, 27, 28, 29. We're going to cancel out all the even numbers, because even numbers except 2, which is a super special even number, can never ever be prime. Okay, so even numbers can't be prime because they divide by 2. So we're going to cancel out the even numbers to start with. Okay, the next step is we're going to cancel any numbers we recognize from a times table. Or actually, even quicker than that, let's first recognize, delete any number that ends in a 5 and a 0, because we know that divides by 5. Right. Then anything, when we add the digits divide by 3. So 2 plus 1 gives a 3. That's definitely going to divide by 3. Right. 23, can't think of what times table that's in. Don't think it is, so we're not going to worry about that. 27, 7 plus 2 is 9. Definitely goes into the 3 times table. And the same at 29. So now what are you left with? You're left with 23 and 29. And that's your answer. Okay. Right. we just talked about the next question. So it says, Catherine says 2 is the only even prime number. Is Catherine right? Well, yes, she is. It's only 1 mark though, because we have to give a reason. And you'll say because 2 can only divide by itself and 1. All other even numbers can divide by 2. Right. Okay, as you can see, end of a paper again. We're at indices. So remember, indices again is the more difficult bit. If you're a bit worried about it, we've got a whole separate video on indices and we're going to go through those slowly, but you're going to think of the rules. Okay, so I will put this document up. I'm going to edit the rules so they're a little bit clearer to see. But essentially, when we times, our brain is going to go add the indices. Okay, so we've got M, so we've got 3 plus 4. So that's 3 plus 4 gives us 7. Now here we've got, let me rewrite it bigger, 5np cubed. So that's actually to the power of 3. So we're doing 5 to the power of 3. Remember, that doesn't mean 5 times 3. It means 5 times 5 times 5. So everything in the bracket is to the power of 3. So first we're going to do 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is going to give us 125. Right? And you can write that out, like I said, as a long multiplication if you're not sure. If you didn't know that or you needed to check it. Not a problem. You can write your little multiplications wherever you like. So now we know that's our first bit. Then we've got this bit here. We've got n. Oh, I don't know what's happening. We've got n to the power of 3. So we've got n times n times n. That's just n cubed. And then we've got p cubed cubed. So that's like saying p cubed times p cubed times p cubed. Now remember, when we times, we're adding. So it's the same as saying 3 plus 3 plus 3, or 3 times 3, which is 9. Okay. Right, next one. It says simplify, and that looks disgusting, but we're going to break it down. It's not actually that horrible. They're actually quite nice to do. Okay, so we've got 32. Just take the numbers on their own. You're going to do 32 divided by 4. So what is 32 divided by 4? So that's going to give me 8. We've got q to the 9 over q cubed. So you've got q to the 9 over q cubed. Now, the thing to remember is a fraction is just a fancy word of writing divide. Okay, so q to the 9 divided by q cubed. Now, in our rules, divide is the same as take away. So we're going to do q 9 take away 3. And so we get 9 to the 6. Now, the reason is q to the 9 is q times q times q, 9 times. 2, 3, 4, 5, 6, 7, 8, 9 over 3 times. And remember, anything that's the same on the top and the bottom, we can get rid of. So get rid of 3 of those, get rid of 3 of those, and we're left with 6. So that's q to the 6. So you just break it down into little sums. And then we've got r to the 4 over r. Now, r just means r to the 1, because we never bother writing the 1. So it's the same as having a 1 here. So we can do 4 take away 1, and we get 3. So we've got r cubed. So we've got 8q to the 6 and r cubed, right? Okay, so now we've got lowest. So remember, we had the highest common factor. We've now got the lowest common multiple. And again, I'm going to show you how to do it using the fraction method, where you cancel down a fraction, but also using prime factorization. Okay. Oh, sorry, it doesn't say highest common factor, it says lowest common multiple. Ignore me. It's exactly the same as the previous question, but we're going to do it both ways again anyway. So we've got 40 over 56, and we want to simplify that. Okay, so those aren't numbers that I easily know what times table they go in, but I can see they're both even. So that means I can half them both. Half of 40 is 20, because half of 4 is 2. Half of 56, I'm going to do 50 divided by 2, which is 25. 6 divided by 2, which is 3. Add them up and I get 28. Half it again, because still even numbers. I'll get 10 and I'll get 14. I could even half it again and I get 5 and 7. Okay. And now it's in simplest form. So let's say 40 over 56 equals 5 over 7. So if you remember, what we did is we took the diagonal. It doesn't matter which diagonal you take. You could take 56 and 5 or 40 and 7. I'm going to take 40 and 7 because it's easier, like just from a multiplication perspective. 40 times 7, 7 times 4 is 28. Add the 0, I've got 280. And that is my lowest common multiple. So that's using that fraction method. If you have learnt and what makes sense to you is prime factorization, you may have done it like this. 40, what's the prime factor? So the first prime factor we're going to go with always is 2, which we can half. And we can do 2 again. And we can do 2 again, and we've got 5, and we've got our prime factors. 56, we're going to do the same thing. Half it, which we did up there anyway. Half it again. So this is essentially what we've been doing. Half it again, and we've got our prime factors. And we say to ourselves, let's see what's the most amount of 2s we've got. So, or if we have a look, let's see, there's a 2, 2, 2, 2. So we've got 3 2s, 1 5. So we've already counted the 2s. So we've got to add the 7. So we would do 2 times 2 times 2 times 5 times 7. So essentially 40 times 7, which we did above, to give us 280. Okay. Highest common factor works in a similar way, but this time they've done the prime factorization for you. So what they've done is they've already split it. Now, for the highest common factor, if it's in prime factorization, what you're going to say is what's the same. So let's see, what do they have that's the same? Well, we've got 3 2s here and only 2 2s here. So we have to take the smaller amount this time. Okay, we've got a 3 here and a 3 here, so we can take 1 3. We've got 1 5 and 2 5s, but we just want 1 5. And we'd multiply that. So 2 times 2 gives me, so let's do it in bits. 2 times 2 is 4. Then we can times it by 3, which gives us 12. And then we can do 12 times 5, which we should know is 60. And so our highest common factor is 60. Okay. So I'm hoping that's made sense. So now we're going to look at the calculator questions. So in order to do the calculator questions, what I'm going to do is you should still be able to hear my voice, but I'm going to change the camera so you're looking at my calculator. Like I said, bear with me. First lesson, haven't quite figured all the technology out. We'll probably find some mistakes, but we'll correct anything we have in the notes or anything underneath. Okay, so I'm going to assume you've all got this calculator. If you haven't, try borrow one. But that's what we're going to assume. So if I go down here, video, see if we can get this to work. Hopefully in the corner, you can see my calculator, and I will flip back to it as you look at the questions. Okay, we'll try edit these later, maybe with a calculator section if something seems confusing. So you want to find the value of the square root of 1.44 times 3 point, and you just make sure that what you see in your calculator screen is exactly the same. I've just realized this is like twisted around, so hopefully this fixes it. Let's try this. Stop video. Yeah, okay. So hopefully this is the calculator you have. You may have it, you know, it doesn't have to be in pink, obviously. So we're gonna try scroll down. So you're gonna write square root button, and you want yours to look exactly like that. 1.44 times 3.61. So your calculator display should look exactly as the display, what it tells you in the question before you hit the equal sign. If it doesn't, then you're going to get the wrong answer. So then I'm going to hit the equals button, and it gives me 57 over 25. Now that would be fine, but because the question's in decimals, we want to give the answer in decimals. So we're going to press the S to D button, and it gives me 2.28, and that's my answer. Okay, so if we use the next one, which looks, you're just going to make sure everything you type in exactly as it gives it to you. So open bracket, 3.54 minus 0.96, close the bracket, squared, minus 4.096. So it looks exactly like it does on the screen. We hit the equal sign, we get an answer, and we write that answer down. Right, so 2.5604. Okay, so like we said, what we're now going to do is I'm going to go backwards, and I'm going to show you how to use your calculator. Actually, we'll just do it on the next page. So we're just going to look at using your calculator to do a few of these questions. So things you can use your calculator for to do your highest common factor, your lowest common multiple, and so on. So let's first, right, and flip me back. Okay, you should be able to see me. I'm not sure why you can see. Ah, there we go. Right. So what we're going to do now is we're going to look at using our calculator, but to do some of those skills. So what are the tricks and tips we can use for standard form, highest common factor, lowest common multiple? How do we write the fraction in using a fraction button? How do we do the prime factorization straight away? So there's a few bits in this topic that if a question comes up in a calculator paper, we know what we can do. And obviously we've just looked at all the skills in a calculator paper. So what we're going to do, hopefully this works. Okay. And I'm not sure I can annotate on here. So stop share. Right, I'm going to try one more thing if this works. Otherwise, I'll do it a different way. Just deciding to load. Okay. And okay. So hopefully you can see my desk and you can see my calculator. And if I've got this right, I should be able to. I'm right on here and you can see that. Okay, good. Right. Okay, so say I want to find, like we did in the previous question, the highest common factor so we're going to look at the highest common factor of 40 and 56. Okay. And then we're also going to look at the lowest common multiple. Right. So exactly like we did before, we're going to write it as a fraction. But the advantage of having the calculator is we can use this fraction button. We can type 40 and we can type 56 in. So I'm using these arrows to go up and down, and I'm going to hit the equals button. And that gives it to me as its lowest, as it's in its simplest form. So that tells me it's 5/7. Now, once I've done that, I can look at my diagonal. So remember last time we did 40 times 7. Let's now do 56 times 5 and hit the equal sign. And we get 56 times 5 equals 280. So 280 is my lowest common multiple. So even though it's the bigger number, it's the lowest common multiplier. You've got to get it in your head. It's when I multiply the diagonal, it gives me the lowest common multiple. Now let's look at how we do the highest common factor. So we did that same method where we'd write it as a fraction, get it in the simplest form, and then all we're going to do is we're just going to take one number and divide it by the other, meaning we don't need to worry about diagonals here, right? All we're going to do is we're going to go and we're going to have a look, and we're going to take the bigger number and we're going to divide it by 5. So we're saying, how do we go from 40 to 5? 40 divided by 5. So we're going to do 40 divided by 5 is 8. And 56 divided by 7 is 8. So 8 is my highest common factor. So the way you remember this, right? Multiple, diagonalize, multiply the diagonals. For the highest common factor, I'm going to take the top common, a common row, and I'm going to divide them, right? Hopefully that helps. Okay, let's look at some standard form stuff. So if I have something in standard, if I have to write something in standard form, so 0.9777, whatever it was, equals, and I've got something like that. So if I press this ENG button, it helps a little bit. Can you see it gives it to me? It's an engineering button where we look at things generally in powers of 3. But this gives it to me to the -3. So now I only have to move it 2 more to get it. So I need to move it 2 more to make it 9.77785, so on, whatever it means, times 10. So because I moved it 2 more to the left, I have to take away 2 more, and that becomes to the 5. Okay, so that's the ENG button that helps you with that. Let's take a prime number. So if I want to know if something is a prime number, so say I'm to try and figure out if 87 is a prime number, I'm going to type 87 into my calculator. I'm going to hit the equal sign. Then I'm going to hit the shift button and this button here. So can you see it comes up with fact? And it tells me 87 is actually equal to 3 times 29. So that's in its prime factor form, which means it can't be a prime number. Whereas if I take 17, equals button first, shift fact, it stays as 17. Can you see nothing's changing? 17 is a prime number. Say I take 5, 8, I can take any number, 4. Now I know that's not going to be a prime because it's an even number. But if I hit shift and fact, it converts it into the prime factorization. So that's how you get your prime factorization. So there's just some basic bits about your calculator. So you've got your SD button, you've got your ENG button, which we've learned about today, your fact button, and you also can do standard form quickly if you need to type in your calculator using this times 10 button. But what we'll do each week is make sure we cover more and more calculator tips. So by the end, you've got all the different bits for the calculator that you need. Okay, so what I'm going to do, we're going to edit those notes because, like I said, you guys are like a bit like my trial run, unfortunately, today. But we're going to edit the notes out, anything, and make them work for you. And they will be available probably in the next couple of hours. So you'll be able to, have a look at them. For those of you that are doing the entire course with me, we will start at 4 p.m. again on Saturday. We'll always start at 4. I've given myself and blocked out till 6 o'clock, but we won't always use that time. And occasionally it might be a bit longer, but obviously if you're not free, you can always watch them and look at them later. So I hope that's useful. Have a look at the questions. Please comment. Let me know what you think might be better. The questions today were taken from Edexcel, from AQA. I think we might have a few OCR in there, but we've tried to take them from a range of exam boards. And we will be doing extra exam papers as well. What I'm hoping to do, subject to time and life, which has recently been a bit crazy. Those of you that sort of follow my Instagram might know that. But it's hopefully going to settle a bit. Over the next few weeks before your exam, I'll try do an exam paper a week as well. And that will be on YouTube. So hope that's been useful. And look forward to hearing from you guys. And make sure you see you next Saturday.